All right, guys, so kind of finishing up from yesterday's notes here. We got through the first several examples, and the focus of the lesson was to be able to graph quadratic functions that are in the form ax squared and ax squared plus c, right? We talked a little bit about how that a term would affect like the shape of a parabola. It could stretch it out or smush it down. And then that C term, if we add something on at the end, that's going to move it up or down. All right, so that's kind of a brief little overview of what we did yesterday. What we did not do yesterday was the word problem. So we're going to finish up with a video of that. All right, so it says, an acorn drops from a tree branch 20 feet above the ground. The function h equals negative 16t squared plus 20 gives the height of the acorn in feet after t seconds. What is the graph of the function? And then also, how many seconds does it take for the acorn to hit the ground? All right, so I'm going to go ahead and pull up Desmos to try to help us graph it and to also try to help us answer that question. I will say before I do that, though, this is kind of like the word problem from this chapter. It's always like the falling object problem. Again, think back to our like preview, the basketball in the air, right? It goes up, it comes down. So a parabola is a good model of this kind of scenario. So you'll see this problem kind of come back again and again. All right. Anyways, as far as graphing it goes, I'm going to go ahead and pull up let's see. Well, I guess I'll just type it in again. Okay, there it is. Never mind. All right, so here it is typed in. All right, y equals 16x squared plus 20. Now, notice I did change it. What it says on your notes is not exactly what it says there. Okay, it says h equals 16t squared plus 20. I'll just tell you that Desmos does better when you use x and y. So that's why I changed that. Okay, so if you use like h and t, it'll show you a graph, but then it won't like show you a table and stuff like that. So I would suggest always go with x and y as far as Desmos goes. All right. So we see, we kind of see a rough graph, and now we're going to dig into the details as far as actually putting something on our graph that makes sense. All right, now this is a word problem, right, where my x-axis is my time axis and my y-axis is my height off the ground axis. All right, so in terms of like what we care about and what doesn't make sense, in a word problem, like all what we don't care about is over here. Okay, so so this part of the parabola like just doesn't, or not, we'll just say it's not applicable here. Okay, we really just care about the first quadrant where time is positive, right, and where feet are positive. Okay, if that makes sense. So let's go ahead and try to, again, look in detail so I can get a really accurate picture of what I have, okay? So it seems pretty obvious that it goes through 0, 20, it looks like. It's kind of tough to tell where it crosses, where 1 goes to, so I can't really tell just by looking at this point. So I'm going to kind of switch over to my table view. Okay, but as far as what I can just see to start, I'm going to go ahead and make a table. So we'll say we have T and H. So we know 0 goes to 20. We can tell that, but we can't really tell anything else. So remember how to get to a table to see more detail. Okay, you go to the gear up there. You click the gear if you're following along. If not, that's okay. But you do need to play around with Desmos or you'll have trouble. All right, now that you hit the gear, I'm gonna click the table looking thing, and there you go. All right, there's the table. So I can see that 0, 20 is on there. I can also see that 1, 4 is on there, right? Everybody see where I'm looking at? 1, 4 right there. Okay, so 0, 20, 1, 4. So 1 goes to 4. So just to summarize, what that means is after 0 seconds, it's 20 feet in the air. After 1 second, it's 4 foot. It's 4 foot off the ground. So very close to the ground after 1 second. Now, that's not going to be enough to graph. So watch what you can do with your table. All right. Now that you're into the table, you could say, all right, so what happens if, where is it at after I say a half a second? So let's say if I type in 0.5 there. So if I type 0.5, it tells me that 0.5 goes to 16. All right, so I'm gonna have that that I can put on my graph. Again, I'm just trying to get details here to include to make my graph really accurate. So after a half of a second, I'm 16 feet in the air, right? And so we'll go ahead and put that there. So then we want to figure out kind of like, all right, so when exactly does it hit the ground? All right, so we know it happens sometime after 1 second and way before 2 seconds. So let's just start guessing and checking then. All right. So I have 0.5 up there. So let's try to check 1.1. That's a tenth of a second after 1. So 1.1 goes to 0.64. So that puts us really, really close to the ground, right? 0.64 of a foot. You know, we're way down there at that point. We're pretty much to the ground, right? Where is the ground as far as the height goes? 0, right? The ground is 0 feet off the ground, okay? So 1.1 goes to 0.64, and just so we can see it, let's see where we're at after 1.2 seconds. So I'm gonna go ahead and type that here. All right, so it says negative 3.04. So I'm gonna write that down. 1.2. Negative 3.04. All right, so let's go ahead and just analyze what we have then, and we'll look at putting it on the graph, okay? So 0.64 feet off the ground, we said that's really close, all right? I'm going to just put in parentheses. That's really close. All right, negative 3 feet, something that doesn't make any sense, right? The acorn's not going to go and dig 3 feet into the ground, right? So, so we'll just say that this answer, we'll just call it not applicable. Okay. Once we hit the ground, our function is kind of doesn't work anymore. All right. So let's go ahead and graph what we have. And again, we are only going to be looking at the first quadrant here, right? So I'm just going to highlight the first quadrant. So I'm just going to be looking here and here, okay, at nothing else. So then I kind of run into a couple of issues. It only goes up to 10. I want it to go up to 20, right? So what could I count by on my y-axis? Robert? You count each block by 2. Count by 2s, right? So I'm just going to say scale for this one equals 2. We don't really need to scale our x-axis, but since we're counting by, like, since we zoomed into 0.5s, let's count by 0.5s on our x-axis. So I'm going to say for my x-axis, easy for me to say, my scale is 0.5. So that'll give us a neat little picture of what we have, okay? All right, so let's go ahead and graph our points. So we have 0, 20. On my graph, that's going to look like 0, 10. Okay, so it's going to be right there. We have 1/2, 16. On my graph, that's going to look like 1, 8. Right? If I'm considering my scale. we have 1, 4. On my graph, that's going to look like 2, 2. And then we have 1.1, 0.64. We're not going to be exact there, but it's going to be just to the right of 1.5 and almost on the ground. So we'll just say like, you know, like, let me zoom in so I can get a little closer. So we'll just say it's about, you know, that's pretty close right there. Move it around just a little bit. Put it about right there, okay? And then at that point, I'm just going to trace my curve, okay? Just as good as I can go. All right, so it's going to look about like that. All right, notice I didn't go past into any negatives, right? So that gives me a pretty good graph. And then we kind of need to kind of formally answer the question, like about when does it hit the ground? So based on the 1.1 and the negative 3.04, would you say it hits the ground closer to 1.1 or closer to 1.2? What would you think? Sometime between the two of them, what would you think it's closer to?
I think it's closer to 1.1.
I would have to agree, right? Because 0.64 is closer to 0, right? So yeah, we could say that it hits the ground very close to 1.1 seconds. Okay, so let's go ahead and finish with that. The acorn hits the ground. And you might note there that that's where h equals 0. H equals 0. Very close to 1.1 seconds. All right, so we kind of got into the nitty gritty on this one. We kind of played around with the table a little bit more, so that's the kind of detail that you can get out of Desmos. And I'm going to go ahead and end the recording there. So I'll go ahead and attach that to the materials for yesterday. So if you want to re-see that one, that's where it'll be, under the 9-1 material.